All right, well, welcome back to the Gas Compression Podcast. Really excited. My guest today is Jim Dettore, and he is the owner, founder, president of Failure Analysis Services. And something that is near and dear to everyone in the gas compression industry is failure. It's something that everybody deals with. I don't care who you are. We've got rotating parts, and they're going to fail. And so, Jim, well, I'll let him tell you about failure analysis services. But first of all, Jim, I start every show just kind of asking how you got to be in this industry and how you got to where you are. So, what's your background?
So my background is I started turning wrenches on heavy equipment, construction equipment and whatnot in Southern California, probably 86, 87, and had a pretty strong machining background prior to that, and welding, cut, fit, and fab stuff, but have never worked on diesel engines or heavy equipment. And that progressed into working for a couple of contractors for about 5 years.
Okay.
And over that period, learned quite a bit, mainly from mentors and reading service manuals and whatnot. I love to read, and and I ended up getting a job with the local Caterpillar dealer, and I worked there for 6 or 7 years, and then went to another dealer and worked there for a few years and gained some more experience and different levels of repair, always on the service side for the most part. And doing that, I was in a field truck for a lot of years, did a lot of troubleshooting and diagnostics, and they invested quite a bit in me, both dealers did, in training me with various technical training classes. And one of the first classes that I went to was Caterpillar's Applied Failure Analysis class. And by the way, I had no idea that I'd ever end up where I am, owning a company that teaches it and consults with it. But I left from there and moved to Michigan. I've kind of lived all over the country working for different cat dealers. I've worked for 5 dealers over the last 25 years, I guess, and different areas of service, and then service training, service management, and technical services management, as well as executive level general management at a dealership. So it kind of gave me a well-rounded experience, as well as the necessary business skills and business acumen to own my own business and manage my own business and treat our customers the way that I wanted to.
Mm-hmm.
So this business, Failure Analysis Services, I am not the founder. I'd like to be the founder, but the founder is the gentleman who originally wrote the failure analysis training program for Caterpillar, and his
Oh,
name was
wow.
Daryl Davis. Yeah. So Daryl retired from Cat in 2002 after working there about 32 years. And in about 1984, he originally authored the training program, Applied Failure Analysis for Caterpillar. And he did a lot of study and got to meet with engineers and metallurgists and a lot of factory people throughout different various manufacturing processes and steel making and stuff like that. And in 2002, he retired, and he wasn't ready to be done. So he ended up starting his own business, which was FAS. That's what most people know us by, is FAS, but it stands for Failure Analysis Services Incorporated. And Daryl was the guy that taught the first class that I went to way back in, I think it was 90, 91.
Wow.
And Daryl owned that business up until 2012, Michael. And in 2012, he was training in Ghana, West Africa, pretty far from home. He was 72 years old doing what we do now. And he suffered a heart attack over there. And unfortunately, he didn't make it. So he passed away, and the business came up for sale. So my wife and I ended up purchasing the business from Daryl's widow, Candy Davis, in 2014. And it hadn't transacted in a few years after Daryl's passing. And so we had to build the business back up. And what was kind of exciting was I didn't have much experience in the gas compression world, really at all. I'd heard of it, and I used natural gas in my stove at home, and that's kind of where it ended. But our first customer ended up being an old customer of Daryl's that was Mid-Con Compression, that was owned by Chesapeake Energy
Mm-hmm.
back in 2014, 2015. And they were the first people to book classes with us. And I studied the material. I rewrote some stuff. I kind of freshened everything up a little bit to like make it look a little more current. And we ended up doing quite a few training classes for them, our level 1 and our level 2. And that kind of morphed into the first couple of classes that I did for them. I did them at their training center in Cleburne, Texas. And I talked to the training manager at the time about the classes that they offered there and see if I could maybe join one of the classes or just sit in as an observer. And he said, no, we'll set you up and you can come over, get a hotel and stay for the whole week. And I went through their general gas compression level 1 class, and they had 2 instructors teaching it. And it was a real mind blower for me. I mean, these guys were so incredibly technical when it comes to setting compressors and tuning engines and the different gases and the different fuels and just everything that went along with it. So that's kind of how we got our start in gas compression. And then over the years, I've met quite a few different people. Some of the people after MidCon, I think they either closed or were bought out, and they sold a lot of equipment off. And we started getting contacted by previous employees that went to work for other gas compression companies, places like, I'm sure you've heard of them, Archrock and Enerflex. And now we've trained for a lot of different ones. I think maybe Kodiak and we've trained for aerial compressors. Some of their engineers as well, and just quite a few different ones in the gas compression industry, as well as doing quite a bit of failure analysis consulting for different gas customers that have had wrecks that they want diagnosed, or they want a third party opinion or evaluation of the failure. But we've taken that business and grown it into, I'm kind of proud to say that the first year we were in business, we did 6 classes. And I had quit my job at the dealer, big salary, car, all the benefits, and kind of, I think you know what it takes to be able to kind of jump ship, have your own business and start it off. And there wasn't much business because of Daryl's passing a few years prior, but we turned it into 2019. I think we did 30 classes that year.
All right.
So, and not just gas compression. Also, we train in the marine industry and construction and mining equipment industries as well. But a lot of our business is gas, and we really enjoy working with the gas compression folks and working in that industry. But COVID hit, so we were back to 6 classes in 2020, and that was kind of a bummer, But we got through it, and I think this year we're scheduled to do 35, 36 classes.
All right.
We've got one coming up in June. It's what we do. We call it an open enrollment class. So it's open to the public. Anybody can come to it. So we've got a bunch of folks, primarily gas compression customers, along with a bunch of folks from Shell Lubricants attending that class. And it's the week of the 7th in Fort Worth, Texas, and it's full.
Oh, really? I was just fixed to ask if anyone wants to sign up, how do they do that? But it's full.
So that class is full. So the next one will be in Colorado Springs, Colorado, the week of October 8th, I believe.
Okay.
And then we're looking at possibly doing another one in Midland, Odessa area of Texas later in the year. But
okay.
We'll start rolling with these again, and we'll publish them, well in advance so people can get an opportunity. But we don't just do training that way. We also do on-site classes for our customers, which means that the customer calls us, we give them a quote, we quote the travel and mileage and the course fee, and they can send up to 15 people to a class. And we come to, like, if we were to do a class for you, we'd come right to your facility. We'd unload and set up. We bring everything that we need except the room, the table, and the chairs. And
wow.
We'd unload, set up on Friday. Yeah, we carry a lot of broken junk iron. It's kind of a Sanford and Son kind of deal, if you know what I mean. But that's our theme song. But we set up, and then we come back Monday morning, and we teach a 4-day curriculum, and folks really enjoy it. I haven't heard any negative comments from anybody that's attended. They get really excited about the new skills they learn, and they have a good time throughout the course week. And we kind of change their perspective a little bit at how they look at parts and how they look at failures and how they communicate with people in general. It's part of the stuff that we teach.
Well, let's just, a broad overview of what is failure analysis versus what like root cause, in our business, I'm in the machine shop business. So something fails and we always hear the word root cause. Give me the broad overview of what you define, failure analysis and why it's so important in rotating equipment.
Well, let's start with root cause. So root cause is what we're trying to get to through the process of failure analysis, right? So failure analysis, it encompasses critical thinking skills. So that's analysis and fact gathering, along with inference. So coming up with a conclusion, and we focus on a fact-based conclusion of the root cause of the problem. But it's all about gathering as much factual data as possible, because facts are hard to refute, and then being able to interpret those facts and identify particular events that occurred that maybe created facts. I'll give you a quick example. If we have a bearing fail in an engine or a compressor, and that bearing spins, well, there are a multitude of reasons that can happen. One of them might be the lack of lubrication, and we teach folks how to gather facts and how to use those critical thinking skills in the analysis to determine, well, was it an oil consumption problem? Were we using the wrong oil? Did we have oil leaks? Was the oil level not being checked? Things like that. Was it a problem with the pump, or a problem with the bearing, or a problem with the crankshaft? So we teach people how to inspect all these areas and how to ask themselves thoughtful questions about, well, if you're looking at a bearing and you see the damage that's occurred to it or the crankshaft, ask yourself, what could cause this specific type of damage, and a specific wear type that we teach you how to analyze. And once you identify those events, we use the process of getting those events on a timeline. And so once we get them on a timeline, then we can put them in chronological order, basically the sequence that they occurred in. And through using the skills and knowledge that you gain through failure analysis training, it gives you the ability to put those in chronological order. And if you've done a good job and you've done it right and thoughtfully with no preconceived ideas, then the first event on the timeline should be the root cause that you're looking for, like in your machine shop, right? So curious, in your machine shop, do you guys have mostly manual machines or CNC machines?
Mostly manual machines. The bulk of what we do, our main business is reconditioning compressor cylinders, spraying cylinders, piston and rod, doing valves, stuff like that.
Gotcha. So you're looking for repeatability a lot when you have multiple parts from maybe one customer or one specific brand or type of compressor. And when you don't get that repeatability because maybe a tool wasn't as sharp as it should be, or a machine, maybe the gibs or something on a carriage or a cross slide hadn't been adjusted or tuned up quite right, you lose some of that repeatability. So then we would gather facts in regards to that and then come up with a root cause and then recommendations. Well, it looks like you're going out of tolerance every so often, say once a week. We should check this area with the dial indicator, put an action plan in place, and that problem's taken care of and it goes away. So that's kind of root cause analysis 101, if you will. That's what it's all about.
Now, will your gas compression customers call you and hire you guys for like a single crash? So let's say they've got aerial, most people are running aerial compressors. So you've got a 4-throw aerial unit and there's a crash and everyone starts pointing fingers. The machine shop's fault. Well, it's the mechanic's fault. Well, it's the operator, do you get calls like that just on a single crash, or is it something like it's got to happen multiple times, or it's got to be a certain size of, failure that they'll get you involved in?
So it's a single crash a lot of times, but it goes more than that. So sometimes it's maybe a component that was rebuilt by, let's say, an aftermarket services company, whether it's the engine or the compressor, and they had rebuilt that component for their customer, similar to the work that you do in reconditioning parts, right? And then it goes out and it fails for some reason. So our customers will usually call us to do the failure analysis on it. And that has led into several different things, not only analyzing the engine or the compressor failure, but also kind of morphing into maybe some quality control for the next overhaul process. And then that would be the end user hiring us for that, to make sure that everything gets put together right. They're a little nervous because it's a lot of dollars involved, especially when there's a lot of downtime. Mm-hmm. And then we'll go in and we'll do some QC and make sure that things are going together clean, things are torqued properly. Cleanliness is a big issue, right? Especially when you're overhauling a unit like that. And then that is also kind of morphed into some training for some of the overhaul techs for a couple of different companies that we work for. So we sort of do all the above. We'll consult on failures, and we do that for not just for gas compression customers and companies, but also for a lot of Caterpillar dealers. You know, it's a popular combo is the Cat engine and the aerial compressor, right?
Right.
So having a lot of Cat background, you know, makes that real helpful. But we've also looked at some other compressor parts and not just aerial, as well as not just Cat engine, some Waukesha stuff and some turbine stuff. So whatever it takes, the processes and the theory applies to essentially all metals.
Right. Do you have a common, the answer is probably no, but is there a common theme that you see in a lot of failures? Like, you know, the 80-20 rule, right? So 80% of the problems come from 20% of the issues. So is it something like cleanliness, lubrication? Is there something you could swing a hammer at and say, man, if we could get this right every time, we'd be taking care of a lot of problems?
Boy, you hit the nail on the head with the cleanliness comment. And yeah. I'm going to say that's probably contamination and cleanliness is probably 75% of all the failures that we see when it comes down to the root cause. And more often than not, that contamination happens during assembly or during service work. Anytime that the compressor frame is opened up, or anytime that the engine is opened up, we give the opportunity for contamination to enter. But a lot of guys are, you know, they do a lot of work in the field, and it's tough work with the wind blowing and dust blowing, and it's tough to keep it clean. But you know, you got to do your best.
Well, let's talk about inspection, improving inspection procedures. So I'm gonna have you back on. You've already agreed to it, so I'm gonna hold you to it. Because I think, this is a really valuable thing for the industry to get your insight and intake on preventing failures. And so one of the big things is the inspection process and how we can improve that. So where would you start, and what would you say to mechanics in the field and people in the shops? Like, what are some things that they need to be doing in that inspection process?
So let's see. Kind of the way we teach it is, first and foremost, always be in inspection mode. When you pull up on site and you get out of the truck, what do you see? What do you smell? What do you hear? What do you feel? Are things getting hot or cold when they should be the opposite? Always be in an inspection mode. And then we teach guys to look for, well, the common senses. You know, what could you physically see that would indicate that there was a problem with this unit, whether it's the compressor or the engine? Leaks are a big one. Broken or missing fasteners are another one. You know, heat and discolored paint, things like that. So teaching that, and then also teaching them to, you know, listen for problems. It sounds like knocks or squeals or grinds or clunks or bangs. But aside from that, when it comes to inspection, what we teach primarily are, wear types on parts, and we teach 7 different wear types and how to recognize those types on different components. They don't have to be failed. They could be a part that maybe you're replacing because you've troubleshot it and you think that it needs to be replaced, but maybe you're uncertain. Well, we can teach you how to discern, is it truly worn or not? Is it a part that needs to be replaced? Is it something that could be cleaned up or salvaged? Because we all know there's a big parts availability issue right now, and the supply chain stuff. But teaching guys how to recognize those different types of wear that we see, and what they mean. how are they created? And once again, asking themselves those questions. Well, what could cause this specific adhesive wear or the abrasive wear? And the abrasive wear is usually due to contamination.
Mhm.
But what could cause the adhesive wear or the cavitation erosion or just simple corrosion of surfaces? So when we talk about inspection, that's really what we're looking for. We get out to a lot of units that just have a lot of oil leaks on them. And I hear from technicians, well, it's this brand engine and they're known for leaking. Well, okay, I've worked around a lot of them that don't leak. When I pull up to something and it's leaking out of every cover and every gasket and every seal, it's usually a strong indicator to me that we've got some really high crankcase pressure going on, and it's just blowing it out wherever it can.
Yeah.
But being able to recognize those things, misalignment issues, different types of wear on fasteners and couplers, and just being able to recognize, I guess, Michael, I could say that some folks, and not everyone, but they get complacent working on the same thing day in and day out and go to maybe to a different unit, and it might be a different compressor, it might be a different package, but it's doing the same thing. So it's just get out, do my standard checks. When someone with really well-honed inspection skills can get out and walk around it and notice that, hey, that line's vibrating. So that vibration is going to potentially lead to a crack, and that crack's going to lead to a leak. And that leak's going to lead to downtime or a thermal event, which we don't want either, right? Because that affects production and dollars. So when we talk about inspection, those are the kinds of things that we're looking for.
So let me ask you this. If someone has gone through your class and are they going to leave with materials that, like when a mechanic pulls up to an operator technician pulls up to a unit, they've got a piece of paper or a notebook that says, this is what I'm supposed to do when I get out of this truck. Do I see, smell, or hear anything? Check the box. And then step 2, check couplers. Step 3, is there kind of like a list of things that could go down to kind of take the guesswork out of it?
Well, as far as specific inspection processes for specific components, maybe not so much, but that's a great idea. And it's something I'm probably going to put together for future classes.
Yeah, I was just thinking, I mean, if you, especially, of course, we got labor shortage, just like part shortage. So we're trying to train mechanics in this industry and throw them out as fast as we can in a truck with a crane on it and say, go take care of this unit over here. But if they could pull up and they take the guesswork out of it, like, all right, step 1, check this. How's it look? Step 2, step 3, step 4, kind of doing that kind of stuff. That'd be super helpful.
I think so. I agree with you. So when they take our class, what they end up leaving with as far as materials go is they have a small notebook, and I think it's like a 6 by 9 inch notebook. So it can sit on the dash of your truck or in a backpack pretty easily. It's not like a big 3-ring binder that you get from a lot of technical training schools or classes. But they also leave with a USB jump drive, and it has all the training presentations with quite a bit of literature attached to the bottom of each slide, giving good, thorough descriptions of different types of wear and different types of fractures and things that they might see that could help them go in the right direction, rather than the wrong direction, which can waste time or possibly maybe not avoid a failure or a crash from happening, right?
Mm-hmm.
But they leave with that. And then we also have some other handouts that we give them, paper copies that they use in class, but there's also digital copies in a reference folder on their jump drives that are analyzing different wear types and analyzing different fracture types. And I tell the guys in class, these handout sheets they're really golden if you use them. We teach them how to use them in class, and they're very intuitive, by the way. But if they follow the process steps on each one of those and they avoid the preconceived ideas, which that's the toughest part. That's the discipline that you have to exercise. But they avoid the preconceived ideas, they can usually get to the problem area and make a pretty good call on it. We train a lot of people, and we have quite a few of our customers that stay in touch with us. And they'll send us pictures and maybe want a second opinion, or usually if you send me pictures, I'm going to respond with a bunch of questions. That's just kind of how that works. But they do this, and it just helps them make them better at their job, right?
Well,
And
yeah, I was going to ask you
make
that.
them more efficient. So
Yeah, let me ask you that. So if someone goes to your class and then 2 months later they're dealing with a crash, they've got a failure, can they? I mean, you said you'd ask a bunch of questions, but could you look at some pictures and then almost, just via email kind of diagnose problems? And do you charge for that, or how does that work? If someone said, "Hey, just take a look at this."
Yeah. So what we do is if you take our training class, then you get my contact information. So you have my personal cell phone number and you have my email address. And I let them know in class that, look, anytime you guys run into something and you need another opinion, or you need an educated guess, or maybe a swag, right?
Right.
Feel free to reach out. And we also talk about photography and photographing parts and photographing failures in class, because one of the things that we run into is people send people pictures and they're blurry.
Oh,
Right?
yeah.
That's of no value to me. It needs to be a clear, crisp picture so I can zoom in and see what's going on close up. And the students know that, and they learn that in class. But yeah, we become a resource for them, and we hope to be a valuable resource. And quite a few of our students use us in that capacity. It's not just myself; we have another instructor as well, and sometimes they'll reach out to him also to, just like I said, just get a second opinion. Now, if they're wanting it diagnosed, then that means that we have to spend time either traveling to the site and doing our inspection of parts. Then there's fees associated with that. If they want a document produced, meaning if you can only send me pictures and I'm going to ask you a bunch of questions through a process of an interview, and maybe you send me some oil sample reports and some maintenance history. But if you want a document, well, there's going to be a fee associated with that as well. But to give me a call or to shoot me a text message, if I'm teaching, well, then I have to respond at break or after class. But I respond to everybody and try to help them out as much as I can. That's what makes it really enjoyable, is when people reach back out and
That's cool.
want some assistance.
Do you have anybody on like my side of the table that uses you or goes to your classes? Because, on the machine shop side, we don't know anything about the operations, right? So we're the third party people. So we get some parts in, we repair them, we spray a cylinder, we build a new piston, whatever. We send it back out the door. And then a month later, someone calls, says, we had a crash. And we're like, okay. And they're like, well, are you going to warranty it? We're like, well, what happened? Well, I don't know. And we're like, well, was it lubricated correctly? Was it? Yeah, it was lubricated. We always kind of get into this thing like, we don't really, we're not the experts. We're the machine shop. And so do you ever have people on my side of the table taking your classes and getting involved?
Michael, thinking back, I've had just a couple of machinists attend our class, but it would absolutely be valuable to most machine shops to have at least one person that is trained in it.
Yeah.
And kind of embraces it, because it's kind of a diminishing skill also. If you don't use it, you kind of lose it.
Yeah. But, no, I'm thinking I've got someone in our shop foreman. I mean, it would be super beneficial for him to go through your class, because that's what happens. We get, kind of grainy pictures from the mechanic and saying, hey, this cylinder is wearing too much on this side. We're like, well, we don't even know what questions to ask. And so that would be really helpful.
So I could definitely see the benefit in that. So kind of just to talk about, who do we train, right? Yeah. Who attends our classes? So we train a lot of technicians. We train a lot of territory service managers or area managers for gas compression companies. We train a lot of welder fabricators as well. We train a lot of service managers for dealerships. Trying to think who else. Quite a few engineers have sat through our classes, not just engineers like from aerial compressors, but from like Lockheed Martin missile defense systems.
Wow.
So we get some folks in there that these were young engineers, and they were there primarily for the fractures portion of the class, because when they design something and it blows up, they have to inspect the fracture surfaces to make sure that it blew up correctly.
Right.
Yeah, so it's kind of crazy, but we get a lot of that. Then we get a lot of warranty administrators also,
Hmm.
for different dealerships, and then we also train for a pretty good handful of major equipment manufacturers, and we're training their territory reps as well, because kind of like you said, if they aren't trained in that and they have a failure, and the service management or a technician texts them a couple of pictures saying, hey, we want support on this, and they're not sure what they're looking at or what could potentially cause the problem they see. So they get benefit from it, just like your shop foreman would.
Yeah. So so if you were to give the top three tangible or five tangible things that people out there need to be thinking through in inspection wise, when they're pulling up to a unit, the first thing they need to do is they need to listen, smell, and look. Is that what you said? What do you see?
I
What do you
would say,
smell? What do you hear?
yeah. What do you see? What do you hear? What do you smell?
And be ready to like write that down.
So that's the best thing is to document it. Don't try and keep it all in your head. There's just too
Yeah.
much stuff you go through while you're on site. So document everything that you see, and then if it can't be repaired, then well, hopefully then that report can go back to a service manager and they can get the repair scheduled, right?
And then what's the second thing?
So I would say the second thing would be so we're talking about inspection still, right?
Yeah, yeah. So you're coming up on a unit, someone's coming up to look at a unit. There may be something wrong. They're not sure. And they come up to this compressor, and what's
So
the
I'm doing
second?
all the visuals, and then the next thing I'm going to want to check are fluid levels, and engine oil level, coolant level, compressor frame oil level, maybe also day tank levels, to be sure that nothing has the potential of going low. But not just checking the level, but maybe also pulling the dipstick, maybe smelling the oil. Does it just smell like engine oil, or does it have some other odors to it, like coolant or something like that? So those would be probably the next thing that we would recommend that you would check would be the fluid levels. You're doing your walk around visual first usually,
Mm-hmm.
and then probably fluid levels.
Okay. And then the third thing?
The third thing, it seems like with compressor frames and engines driving rotating equipment would be possibly the mounting that we see. So we run into situations. I'm not sure if you're familiar with the term soft foot.
Mm-hmm.
So a lot of engines or compressor units, if they're not mounted on a skid, then they're grouted in, and sometimes you get a good grout job, you get a bad grout job. Sometimes you have excessive oil leaks, and that deteriorates the grout. So this starts to cause alignment issues,
Mm-hmm.
and something in the larger engines that we call web deflection, from the block flexing, and that can damage internal engine parts, bearings, crankshafts, blocks, and couplers and coupler bolts alike. So probably the mounting, and then obviously any drive element, and any cooling element. So the cooling element would be not only maybe the belts and pulleys on the front of the engine, but also the cooler cores. And when cooler cores start getting plugged up, things start to overheat. And that's when you need to maybe call the guys over at Ultimate Chemical. They do a pretty good job of getting those things cleaned up for you.
Yeah.
But we recognize a lot of those problems, just in the visual inspection. And I would say combined with that would probably be, looking the C part, looking for vibrations. So there's a lot of piping and a lot of tubing going from things like pulsation bottles and going to and from the cooler stages, back to the compressor. And when those things aren't isolated properly, then they start to vibrate. And when they start to vibrate, it usually leads to a crack and a leak. And like I said, some kind of thermal event. So looking for those general things would probably benefit technicians the most. And you can do it relatively quickly. The nice thing is the more you do it, the easier it becomes, and it becomes second nature.
Mm-hmm. Now, do you see, so those things you just listed that, that seems like common sense, right? But we all know like those that do great things, they do the common things uncommonly well. And so what do you see coming out of, I mean, maybe people that are taking your class, your courses, that have maybe gone through a VOTEC school or something, maybe I know OSU has a compressor course, and I think there's one up at Liberal. And so do you feel like people are coming out and coming into this industry with a pretty good idea of what it takes to do this?
I think that they learn the skills necessary to maybe diagnose problems, system problems, things like that. They learn the ins and outs of it, and the importance of torquing things properly and proper alignment and stuff like that. But I'm going to say that general inspection is something that tends to get missed a lot, or guys just get a little complacent, right? They're around the equipment all the time, and oh yeah, they all do that. Well, maybe they don't all do that, and it could lead to a problem.
Yeah.
Some of them have seen it lead to problems, and they recognize it, so they get it taken care of. But with the VOTEC schools and the guys that come out of classes and schools like that, they learn a lot. They learn a lot of skills and knowledge. But I think one thing that they probably don't learn as much of is the thorough inspection procedures and techniques, and understanding what the deficiencies mean and what the end result can be of those deficiencies if they go unaddressed.
And probably seems just as important as documenting them. Like you said, don't keep that in your head. When you get out, if you don't have something to write that down and make note of it or take a picture, when you get back to the service manager 3 hours later, it's just, we all know it's hard to remember all that stuff.
Oh my goodness. And you probably fielded, 15 or 20 calls, and
Right.
15 text messages in that 3 hours, plus you stopped and had lunch.
Yeah.
So yeah, if you don't write it down, and I hear myself saying this over and over in my head, and I say it in class, write it down, write it down, write it down, write everything down.
Yeah.
Don't take it for granted that you're going to try to remember it, because something could potentially get missed. And the little things end up being really big things when we have a crash, right?
Yeah. Okay. Well, we've got some great ideas on inspection and documenting those things as people are looking at units, at compressors and engines. And then next week, what we want to do is talk about engine and compressor bearings, right?
Yes.
Okay. So are you going to have anything to show? Are you going to have anything to show?
Yes, I will.
Okay, great. So that's what we can be looking forward to next time. But in the meantime, so you can check out Jim. What's the website, Jim? Is it F-A-S?
Yeah, it's www.fas-training.com.
Okay. So yeah, go ahead.
I'm sorry. Check out our industries page, and under industries, you can find the gas compression link.
Perfect. And you're on LinkedIn. People can find you there as well. And so
we're on LinkedIn. Look for my name, Jim Dettore, that's Dettore, or Failure Analysis Services alike. And then we also have a Facebook page. So if anybody would like to like our Facebook page, we would appreciate that.
Awesome. Well, I'm looking forward to the next couple of weeks of doing this. This is it's good education for me and hopefully everybody out in the industry. So look forward to having you back on, and thanks for coming on, Jim.
Thank you, Michael.